The vertex form of the equation for a quadratic function is y equals a times the quantity x minus h squared plus k. The h in the formula represents the x-coordinate of the vertex, and the k represents the y-coordinate of the vertex. The a represents a dilation factor. If a is greater than 1, the parabola will be steeper or skinnier looking than your parent function. And if a is between 0 and 1, your graph will be less steep or fatter looking than your parent function. A also will determine if your graph of your parabola is opening up or opening down. If a is positive, the parabola will open up, and if a is negative, the parabola will open down. Simone, Teresa, Jesse, Erica, and Leon are working together to write a quadratic function to represent a parabola that opens upward and has a vertex of -6, -4. Simone and Teresa and Erica, you will notice, have a thumbs up, and that's because they have written an equation that has a vertex of -6, -4 and opens up. But Jesse and Leon have not written a correct equation. So your task here is to answer these 4 questions. What is similar about all 5 graphs, and what is different among the graphs? On part B, how is it possible to have more than one correct function? And C, how would you tell Jesse and Leon to correct their functions? And D, how many possible functions can you write for the parabola described in this problem? So I'll go back. I'm not going to tell you these answers, but I will point out some features you may not have noticed. You may notice that on Simone and Teresa and Jesse and Erica, they all have an x plus 6 in the parentheses. Simone, Teresa, Erica, and Leon all have a positive number in front of the parentheses. And notice that every one of these have a -4 at the end. So using those things, you can compare and contrast these graphs by typing them in Desmos and then answer the questions that follow. On the next page, you're asked to use technology, and that would be your Desmos graphing calculator, to graph each function, and then use that graph to rewrite the equation in vertex form and in factored form. I will show you part B as an example, and then I would like for you to complete A, C, and D yourself. Okay, looking at the function r of x is equal to -2x squared plus 6x plus 20. I have graphed this function in Desmos, and I spent a little time to get my window adjusted so that I could see my x-intercepts, -2 and 5, and I can see my vertex, which is at 1.5, 24.5. Using those, I can rewrite this equation in both factored form and vertex form. So first I'm going to write this in factored form. If one of my zeros is -2, then I can use x plus 2 for my factor, because -2 plus 2 is 0. And if I have a x-intercept of 5, I can use x minus 5 for a factor. So I'm going to try that. I'll do x plus 2 and x minus 5. So this is r of x equals x plus 2 and x minus 5. Now you'll notice the parabola is opening up, my blue one, and I need it to go down, up and down like this one. So I'll need the negative in front. And not only do I need the negative in front, I need the -2 in front, because that value a is the same in both forms, whether it's in factored form or standard form. The number in the front is going to stay there. So now you'll notice my parabola lines up perfectly, so I know this is my factored form. So now let me find the other one, r of x equals, and I'll use a -2 again. And this time I need to use my vertex to put it in vertex form. So I'm going to click on this point. My x-coordinate of my vertex is 1.5, so that means I need x minus 1.5 quantity squared. And then my y-coordinate of my vertex was 24.5. So that means I need plus 24.5 for my y-coordinate. Once I have the form correct, notice these all three. If you click on one, it'll turn blue. Click on this one, it's red. And click on this one, it's green. But all three of the functions are the same parabola. So that I know I've found all three. The only other thing you have to put in your notes are your zeros. And so your zeros were 5, x equals 5, and negative 2. So x equals negative 2.